called an atom. And right now, this is the home page. And I'm going to show you that you have three options to start with here: atom, symbol, and game. And we're going to start exploring the atom first because this one actually will cover the basic structure of your atom with the three subatomic particles: protons, neutrons, electrons. Then you move on to this little section here where it says symbol, and it helps you understand what these numbers mean. Okay, and this is how we are going to write and express our element symbols so that we are relaying that information correctly. And then this is kind of a fun factor. Once you have the atom and the element symbols down, this will test you in a game format, and so I can show you a little bit of that at the end as well. So here, let's start with this. Okay, so I click on it, and you're going to start off with a blank Bohr model. Now, if you remember, the Bohr model is something that's going to be used as a tool to help us understand where the electrons go, where the protons and neutrons go. So when we're first initially learning this, it's going to be a useful thing. So here, this X, the X marks the spot of where the nucleus is going to be. Now you see these blue circles. These represent the energy shells. Now there are more than two, of course, depending on which period they are in. Okay, so for this simulation though, they don't really go more than two. So that means by neon, okay, we can't go higher than neon. We can't do sodium and magnesium or anything above neon in terms of atomic number. But it'll be a good start for you guys so that we have a good understanding of where our protons, neutrons, and electrons are placed in our Bohr model. So here, this is where the nucleus goes. Remember, your nucleus is composed of protons and neutrons. A majority of the atomic mass is going to come from the nucleus. Okay, your electrons have very little mass. It's actually 1 over 1800ths of the mass of a proton or a mass of a neutron. The mass of a proton and neutron are actually pretty similar. They're one atomic mass unit each. So here, let's start off with picking up one of my protons and placing it in the middle, and automatically it will tell you which element we have just made. Okay, we have created the hydrogen model right here. Okay, so why is it that it's the hydrogen model? Well, it's the hydrogen model because of the fact that we have one proton. Remember, the number of protons determine the identity of that atom. Here's my periodic table of elements. If I want to make it disappear, I can click that. But here, this is going to be useful, so we do want it open. So we notice, okay, my H here, which represents the hydrogen atom or element, has been lit up. Now, if I place another proton here, no longer is it hydrogen, now it's helium. We've got the helium element. Another thing I want to point out before we go on is here, we've got the protons. And I've got neutrons and electrons listed here, but there are no pictures yet, okay? Because I haven't placed any of the neutrons and electrons in my Bohr model. But this is going to keep track of the number of protons, neutrons, and electrons that I place in this Bohr model. Now, I'm going to also open up these. This tells me the net charge, and this tells me the mass number. Remember, the mass number is made up of what? The number of protons and neutrons. So I'm going to place a neutron here, and notice what happened. My helium stayed as helium. And then I placed another neutron. My helium stayed as helium. So no change has been made other than what? My mass number. I don't know if you noticed that. Let me place it back. So helium right now has a mass number of 2 because why? It's got 2 protons. Well, if I add on another neutron, now my number went from 2 to 3. So my atomic mass is really influenced when I put in protons and neutrons in my nucleus, right? Well, let's see what happens to my atomic mass when I add on an electron. Bloop, there it goes. Okay, my atomic mass number did not change. But what did change was my net charge. Okay? In other words, when I didn't have an electron there, it was a positive 2. Now I've got a positive 1. And then let's place another 1 here. And now I've got a 0. 0 meaning what? It is a neutral atom. That means my overall atom does not have a charge. Okay? So what is my net charge depending on? It's depending on the number of protons and the number of electrons right here. So you noticed I have 2 protons. I have 2 electrons. I can even take a look up here to show you that. I've got 2 protons, I've got 2 electrons. Well, I've got 2 positive particles and I've got 2 negative particles. So that means they're going to cancel each other out. And because they cancel each other out, I've got a net charge of 0, meaning I've got a neutral atom. See, it even says it right there. Okay, now let me add on some more neutrons. Okay, and see, hey, look at that. My mass number now is 5. Well, let's go over here. How did I get that mass number? Well, this time, instead of looking at proton and electron numbers, now I'm going to look at proton and neutron numbers, because that's how I get my mass number. I'm going to add the number of protons to the number of neutrons, 2 plus 3, and 2 plus 3, guess what, equals 5. So, proton numbers and neutron numbers combined give you my mass number. Okay, so kind of play around with that until that concept sinks in a little more. Now here, I'm up to beryllium. Beryllium has how many protons? 1, 2, 3, 4. Notice that my charge right now is a positive 2. That's because I have 2 electrons, remember 2 electrons, and now 4 protons. Well, they're not balanced, are they? So therefore they're not going to be neutral, so this is an ion. What is an ion? An ion is a charged particle, a charged atom in other words. And why is it charged? Why does it have a charge? Because in this case, you have more positive particles than negative particles. Well, how many more positive particles do you have? Well, I have 2 more positive particles compared to my number of negative particles, which are my electrons. So that's how my net charge gets determined. I will compare the proton and electron numbers. Okay, now I want to make this a neutral atom, so what do you think I have to do? Probably pick up another electron so that the number of electron equals my number of protons. Notice though, okay, even if I try to put in the first energy shell level, it won't go there. Okay, why? Because the first energy shell level only holds 2 electrons. That's the maximum number of electrons it can hold. Now, the second energy level, okay, oftentimes also called the shell, second energy shell, okay, it can hold a maximum number of 8. So let's go to neon. In order for it to be neon, how many protons do I need? Well, I'll tell you right now, you're gonna need 10. So let me put 10 protons in there. Okay. Well, I have many more protons than electrons. If I want this to be a neutral atom, remember I have to make sure that the proton numbers equal the number of electrons. Right now I'm going to ignore my neutron numbers because I just want to focus on net charge. Okay, so my electron. Where is this going to go? It's going to go now, not in the first energy level because remember that's full. There's no more room for it. But there is still some room in that second energy level. Whoop, sorry, that one just dropped. There you go. Okay. And so it'll find its rightful place. And there you go, 8. Voila. Now it's got a full, okay, second energy shell. And in this case, the second energy shell is actually its most outer shell. So its most outer shell is considered to be full once it has 8. If it has a third energy shell, okay, once again, the maximum number of electrons they can hold, it will be 8 for when we do the Bohr model. Okay, then we will move on to symbols. So here, it's a little different because instead of having the net charge diagram and the atomic mass being shown here, instead you have a element symbol box. Okay, these zeros currently right now are zeros because my Bohr atom here doesn't have anything. Now if I add on a single proton, notice what happens. Okay, remember, the proton number determines the identity of the element. If there's one proton, it's going to be the hydrogen element. Okay, and that red number there represents that red proton number that I actually placed into my nucleus. So the number that's on the bottom left-hand corner is going to be your atomic number, which means the number of protons. Now the number up here is going to represent your atomic mass number, and I think you know what this means. Yep, this is your net charge. Okay, so I'm going to pick up a neutron. What do you think might happen if I drop this in my nucleus here? There you go. It did not change my atomic number because remember, your neutron number does not have any influence over your atomic number. Your atomic number is only your proton number. Okay? But what did change? Well, your atomic mass number did. Okay? So, how did I get that too? Proton plus neutron. Proton plus neutron. 1 plus 1 gave me 2. So if I add on another neutron, that now changes into a 3. Well, if I add another proton, now it's changed the number to 4 because why? I've got 2 protons and 2 neutrons, therefore I've got the atomic mass 4. Now how did I get that 2? Well, that 2, remember, is the number of protons. So 1, 2. Now let's look at let's look at the net charge here. It says plus 2. Well, it's a plus 2 because currently I have 2 more positive particles than negative particles. Well, yeah, I have 2 protons and 0 electrons right now. But if I want to change that number to plus 2, how would I go about doing that? I probably have to add these electrons into my first energy shell. Now I've got my neutral atom. I've got my 0 here representing that it is a neutral atom. Okay, so you can play around with that. And then let me show you. I won't go through all of them, but try all of them. They're actually pretty good. It's a very good way of practicing this. So here it says, okay, find the element. This is the description. It's got 5 protons, 5 neutrons, 5 electrons. But really, I don't need this info. I don't need this info. I just need to know the number of protons. It's 5. So let's count. 1, 2, 3, 4, 5. Must be this element that it's asking about. Now, it asks the second question. Is it neutral or is it an ion? Well, how would I answer this? Remember, it's asking what is the net charge really? Is there a charge? And how do I know if it's charged? Well, I compare my proton number to my electron number. My proton number is a 5, my electron number is a 5. In other words, I've got 5 positive particles and I've got 5 negative particles. So they cancel each other out and I end up with a neutral atom. So I'm going to click on neutral and go click and I get a happy face. Now I can move on and keep going. And this time it's asking it in a different way, but it's the same question still. You just got to ask yourself, hey, how many protons are there? Hey, there's 2. 1, 2. It must be helium. Well, if it's helium, is it neutral or is it an ion? Well, I've got 2 protons and I've got 2 electrons. So they cancel each other out. Once again, I've got a neutral atom. Check. Yes. Okay. So you can keep going and, test yourself out. But you can see they have various ways of questioning you and quizzing you on the same thing. So this is very good practice. I highly suggest you do this. Okay. Check it out. And then go ahead on the website, go onto my Google Forms and answer the questions that are there. It will ask you to provide some proof that you did do the games. Okay, so you'll know what I mean when you get to that question. You might have to take a you will have to take a screenshot of that problem and upload it as your answer. Okay, so have fun, practice, and enjoy.